I'm going to display my paper. Flexural behavior of CSI constraint beams refers with a strain hardening cement-based composite layer. Authors. The authors of the paper were Iqbal Khan and Wasim Abbas. The experiment was conducted with the Kinousoud University Ryan in Arabia Saudi. This is Iqbal Khan. I didn't found picture of Wasim Abbas. Introduce abstract. High strength concrete is often used on construction, with the strained concrete exhibits with compressed strength, but the flexural strengths as cracking are problems for this material. Stone hardening cement-based computers were recently developed as the repair material for improved crack control flexural strength. This paper details the behavior of high-strength concrete beams refers with strain hardening cement-based computers of SHCC and steel fibers. A new method for improving concrete beam flexural behavior was explored by laying layer of SHCC in the Concrete Beam Institute. The flexural behavior of SHCC beams containing steel fibers was also studied using of hay fiber content. 3 types of beams were cast and the series of tests were conducted. The flexural results indicate that the added SHCC layer increased the load-bearing composite of the beams. Adding steel fibers significantly increased the load-bearing capacity of the beam. Concrete is a brittle material that more effectively resists compress than time force. Most concrete factors than deterioration are due to its brittle nature. Cracks form concrete materials due to strange thermal effects and processes. International crack propagation and risk exposed surface due to load includes tensing stress allow deeper penetration for existing external cracks. The cracks will increase with increased outlet loads. Cracking increases the permeability to water, air, or abrasive agents that attack reinforcing steel, which reduces the durability of the reinforced concrete structure. Adding fibers could be a solution to control cracks, including the fibers can bottle the brittle matrix to increase fractural resistance. Concrete posing using unique properties from strain hardening cementitious combinations include limit crackings which have been reported. Cracking on space can be replacing concrete with a cementitious composite, solving the conventional steel reinforced cement to prevent the migration of aggressive substances. In this picture, can you appraise the damage of column with the medium to which it is disclosed, as well as initial crack and sequel serious errors. Materials. It was used ordinary Portland cement, OPC, followed the ASTM-C 115 reference was used as the binder material and was partially replaced by silicon film. Class F fly ash was used to develop the SCHH. Fibers. Two types of the fibers, steel and polyvinyl alcohol or PVA, were used in this study. PVA fibers are normally used to develop SHCC, and the steel fibers are used in the steel fibers reinforced concrete. Methods. Mixing of the concrete and fibers reinforced concrete. High-strength concrete mixture were prepared by green mixing or coarse and defined grades using homogeneous. Water was added to the three mix and the mixed for 1 minute. Water and the ASP dose were added to the mixer and the mixed for 3 minutes and held for 3 minutes. After the 3 minutes stoppage, the material was mixed for 2 more minutes. For the steel fibers reinforced concrete, the fibers were added to the mixture at the end and mixed for 5 minutes to uniformly disperse the fibers through to the concrete. Stand molds were cast on the 28 days for testing. Results. Compression tests for the highly strained concrete without fibers were used to generate straight strain curves for HSP man. The average compressed strength for 3 cylinders was called and plotted in the first picture. And the modulus elastic was calculated for the short method. The stress strain curve variation for the plane and the fiber reinforced concrete indicate that aiding the fiber. Results. Compression tests for the highly strained concrete without fibers were used to generate straight strain curves for HSP man. The average compressed strength for 3 cylinders was called and plotted in the first picture. And the modulus elastic was calculated for the short method. The stress strain curve variation for the plane and the fiber reinforced concrete indicate that aiding the fibers increase the compressive and modulus elasticity. The fibers reinforced concrete spin ductibly behavior without any spin burden, while the concrete cylinder without fibers was completely crushed and shown in the first picture. A direct strategy stress for a strain hardening cement base compute was calculated using the method above. The tense strain capacity was approximately 1.2 and the maximum tensile stress was approximately 4.5. This SHCC layer was laid in the main concrete for determining the structural deformation of the high stress concrete beam under magnetic load. Conclusion. The structural performance of the concrete beams reinforced with steel fibers and the strain hardening cement base composite layer were investigated. The optimum experimental results lie at the following conclusion. First, the strain hardening cement base composite layer in the concrete beam increased the load bearing capacity of the deflation, and increased energy absorption capacity was also observed by the SHCC layer over the plain concrete beam. Second, aiding the soft favor significant increase the beam ductility and load bearing capacity, include the steel fibers increase the post-peak in the behavior of the rain concrete beams. The steel fibers play an important role in the reducing the degradation of the high strength concrete beams. And the last, the test confirmed the people load file and the cracking load capacity of the beam with steel fibers was approximately 27 and 13 and 36 and 136 over the plain concrete with a HCC layer and without fibers